So today we are going to talk about understanding of Cassandra data model. So as you guys know, in RDBMS world we have some data objects. We have some objects like we have tables, we have indexes, we have columns. So on a similar grounds, Cassandra also have key spaces. We have column families, and then we have columns. So which are totally different from RDBMS world. If you, I mean, so you can relate it to RDBMS a little bit. You can, I mean, logically relate it. So just in case of example, key space is more like a database. But if you see the options and the configuration option at each level, which are that are totally different from RDBMS. Okay, so let's start with the database model definition. So what is a database model? So as the definition goes, a database model is a type of data model that basically helps you in determining the logical structure of a database, which helps you in determining the logical structure of a database. And it also fundamentally determines in which manner you want to store your data, you want to organize, and you want to manipulate your data. So this is a formal definition of database model. So it's basically nothing but a database model is nothing but basically the logical structure, laying down the logical structure of a database, right? And it also helps you in understanding how you can store, organize, and manipulate your data. It will, I mean, in case of RDBMS, it will have some entity relationship kind of database model, wherein you have some entities, then you define the relations, and this is how the logical division is done in case of RDBMS. Okay, so why this database modeling is so important? Why we are talking about it? So to explain that, let's go back and see like what kind of businesses we have, what kind of interactions we do online. So let's take an example of Expedia. So on Expedia, you go and you try to book your travel bookings. You try to book your airline tickets. You book your hotels. You book your cars and all other stuff, right? And whereas on Facebook, what you do normal social interactions, you talk to your friends, you share pics and all that stuff, right? So if you see the day-to-day business functions in both of these examples are totally different. Okay, they are totally different. I mean, so what you do in Expedia, it's more of financial. There are some financial transactions are also, you know, like they're also part of your business functions. Whereas in Facebook is all random social basically interactions. So if you see the business itself is totally different. So because of the different functioning of the business, they tend to read and write data in a different way. They tend to create a database in a different way because their data utilization will be different on the basis of their interaction pattern, right? So that is the reason a database should be catered to fit the needs of a company or a business using the database, right? So database model is created to basically customize the database. A kind of is a customization of the database as per the business needs. Okay, because the first thing in a business is you have to finalize which database you're gonna use. Okay, so probably you decided either Oracle or you decided MySQL or you decided Cassandra. Your first decision will be choosing a database, and then once you have the database finalized as per your needs, and then you'll try to customize it as per your needs. You'll try to make a database model which suits all your business functions, right? Because the interactions are different, the way you store and retrieve the information will be totally different. So that's why we have to personalize the database model as per the business needs. So as it says, database model should be driven by the business needs. It is a like we have to start from the business and then we have to plan for the database model. Okay, and that concept is same whether you take example of RDBMS or take example of NoSQL. So it is so the business is one thing which is most important. So business functions have to have to be given priority, and the basis of business function we decide our database modeling. Okay, so what is the difference between database modeling in Cassandra and RDBMS? So what exactly is the difference? So in RDBMS, what we tend to do is we have the data as data is in a normalized state, right? So all of us, we know data is in normalized state. We remove the redundancy in the data, we remove the duplicacy in the data, and we define some entities, right? We define some entities. We say, so in case of probably Facebook, they'll have an entity called users, and in that entity they'll have all the information about that particular user defined. It will say user ID 123, user name, user age, and city, and all the stuff. So all the personal information in one entity. This is how RDBMS world works. Okay, and the data is normalized. Normalized in the way there is, I mean, the duplicacy of the data, the redundancy of the data is removed. We are not duplicating the data. We are storing it one place and then basically referencing it through relations. We have some foreign key, primary key relationships defined that can serve the needs here. Okay, so that is about normalization of the database. We store the data in a normalized fashion. So because we want to make it normalized, so that's why we kind of tend to do ER modeling, entity relationship modeling. We basically have a ER model for RDBMS, and then we tend to create different entities, then define the relationships. So that's the way to that's the way to cater to your database modeling in RDBMS. Whereas in Cassandra, it is totally different. Okay, so what happens in Cassandra? You tend to keep denormalized data. Why we want to keep denormalized data? Why we want to duplicate the data so much? Because there are no concept of joins in Cassandra. In Cassandra, there are no inner joins, no full outer join, nothing. There is no join functionality given in Cassandra. You cannot join two tables in Cassandra. It's not possible at all. So that is the reason we tend to keep the data in a denormalized fashion. We tend to keep the data in one column family itself, instead of defining it in different entities and then joining them. We basically define it in only in one column family. Okay, this is how we do it in Cassandra. And as I said, in RDBMS, what happens is, you basically create an ER diagram, and after that you decide your queries. You decide which queries to fire, and then depending on your queries, you can fine tune your database. You can fine tune, in a way you can create some index, you can partition your table, and all that stuff you can do, right? So that depends on the kind of queries you will be running, or probably in future also. I mean, if you have a new query coming up, you will tune your database accordingly, right? So this is how it happens in RDBMS. But whereas in Cassandra, it is a top-down approach. So you have to start with queries first. You have to write down all your queries at one place. You have to say, okay, these will be my queries that will be run, and the queries should not be dynamic. These set of queries only I can run in future. You have to decide the future as well, in case you think there might be some changes in the near future. So you have to take into account those queries as well, because depending on the query only you will model your data, and it can only cater to those queries. Okay, so since there are no joins, we tend to keep denormalized data in Cassandra and all that stuff. So the data model, once done in Cassandra, you have the database model ready, and then you cannot change your queries are fixed, kind of fixed. We also talked about it yesterday, like in case of Expedia, which makes use of Cassandra a lot at their back end. So what they do, so they basically have a kind of a fixed queries. Only the filter criteria changes. So what do you do when you go to Expedia to book a hotel? You have to give the city name. Okay, you have to give your dates. You have to give how many adults or how many children traveling, and that's it. So there is a fixed set of criteria that you have to define, and you are done, right? So the query in a way it's fixed, just the filter changes. So that's why the database model in Cassandra works that way only. We have to decide the query first, and then you have to go ahead with the database modeling. Okay, so in RDBMS, like how do we start it? So first of all, we have a database server. We set up a database server. We install our Oracle or whatever we want to install in that database server. Okay, and then we create a database in that database server. So this is how it works in RDBMS. Whereas in Cassandra, you have to set up your cluster first. So cluster will may have like more than one node. Essentially, I mean, most of the time it's always more than one node. One node Cassandra installation doesn't make sense. Okay, since you will not be able to uh, you will not be able to utilize the parallelism of Cassandra. if you are not using a distributed cluster instead of one node cluster. So we have a cluster which is a grouping of different nodes. Okay, then we have a key space. So key space is nothing but a analogous to database in RDBMS. So you can, as of now, you can assume key space to be database. So as in case of so in case of RDBMS, what is data? Sorry. So in case of RDBMS, what is database? Database is basically a logical grouping of your tables, right? Logical grouping of your entities. And in case of Cassandra also, key space is nothing but a logical grouping of your tables. And in Cassandra, we call tables as column families. Tables are nothing but column families. Okay. So in RDBMS, in database, we have tables. Tables are what? Tables are just the structure given to your data, right? So you define these are the columns and these are the data types of each column. That's how you define a table in RDBMS, right? Whereas we have a similar concept, column family, but here you don't need to define the structure. You don't need to define which all column it will have. It will just take the column names and the number of columns on the fly. You don't have to decide it well in advance. If you know, you can declare it. So we call that kind of column family a static column family, where you declare it. I mean, if you don't want to declare, that's also fine. We call it dynamic column family. So we have the both the concept. It's a kind of a logical division, static and dynamic. We'll talk about it in detail in next slides. So in column family, essentially, you don't have to define any structure. It is structureless. So at any time, you can add any columns, you can remove any columns, and one of the row in column family can have, like, say, 5 columns, and this in the same column family, another row can have more than or less than 5 columns also. So that's fine, absolutely fine. And you can have millions and millions of columns in a single row. There is no restrictions on the number of columns that you may have, that you can have in a column family. It can range between 0 to millions. So the total size, I think, is somewhere around 2 GB or 4 GB for a particular row in a column family. Whereas in table in RDBMS, it ranges from 64 KB to 128 KB. In case of Oracle, I think it's 64 KB. Or rather, in case of Netezza, which is a MPP system which I work on, I think the row size is 64 KB only. I'm not sure about Oracle and other systems. In case of Netezza, it is 64 KB for sure. Okay, so that's how we compare. Row in RDBMS is only 64 KB, and in column family, the row size can be 2 GB or 4 GB, which is like huge. If you compare with RDBMS, there's a huge difference. Okay, so let's discuss about each and every component of Cassandra. So what is cluster? Cluster is basically a container of different key spaces, right? So basically in cluster we have different nodes, and we have set up some key spaces are nothing but databases. Database name, it's a logical grouping of a column family or a table, right? So you'll have like if you have 5 application to be set up on cluster, you'll have different key spaces for these application, right? You can have multiple key spaces also per application, but like, let's assume as of now you have different key spaces for different applications. So a cluster can have multiple key spaces as well, which is same as compared to RDBMS. RDBMS server can also have multiple databases, right? You tend to create one employee database, you tend to create one customer database, you tend to create one order database. So this is how you do it, right? So you can have different databases, and same way you can have different key spaces in Cassandra cluster. So as it says, Cassandra cluster is made up of nodes. Yes, definitely that is there. So we have different nodes connected together to form a cluster. And basically what happens, Cassandra basically logically, assign those nodes in the form of a ring. It basically reorders the nodes in the form of a ring internally. So it always assume the cluster to be in the form of a ring. So that's why sometimes we call the cluster as ring also, which is a synonym of a cluster in case of Cassandra. Okay. So Cassandra database is specifically designed to be distributed over several machines operating. Yup, we discussed that yesterday. So Cassandra is designed in a way so that you can make use of basically you can elastically scale it. You can add any number of nodes you want at any time. So that's how Cassandra works, and it's very much optimized. It knows how to distribute the data load, or it knows how to distribute the various reads happening on the Cassandra cluster, or any of the load like write or read load. It knows how to distribute it. So it works very well when you have several machines operating in a cluster. You can tend to use commodity hardware, you can tend to use full-fledged hardware, that's your choice. But it works well with commodity hardware as well, which is very much cost effective as compared to the normal full-fledged hardware, right? So this is about cluster. This is what we understand from Cassandra cluster. So when we define key space, so what is a key space? Key space, as it says, is a corresponding, it's an analogous to database in RDBMS. So cluster is a container for key space, as we said, and key space are used to logically group column families, right? So it's a basically logical grouping of a column family, and there are certain attributes that you can set at a key space level. So you can define the key space wide behavior. So you can define certain behavior, certain attributes that are same for a particular key space. So all the column families in that key space will have the same behavior. So one of the example is the replication factor. You can define your replication factor on a key space level, and all the column families in that key space has to use the same replication factor, right? So that was about key space. Okay. So as we already talked about, there are certain we will talk about key space attributes, so the attributes that you can set at a key space level. Okay, so there's something called replication factor. We already discussed that you can declare at key space level. So replication factor is nothing but number of replicas you want to maintain for that key space. So all your data that you write to a you write to any column family in that particular key space, it will be replicated as per your replication factor given. So if it is 3, there will be 3 copies maintained, and as per the industry standard, and as per the cost to performance ratio, best cost to performance ratio, the replication factor of 3 should be used. That's what is recommended. Okay, it will save you from unnecessary blackouts, and at the same time you are not making so many copies of data, so it's also cost effective in a way. So replication factor 3 is what is suggested as per the industry standard. If you see in all the default installation, like if you take the example of Hadoop also, if you take example of Cassandra also, replication factor should be 3 by default. In Hadoop, it is by default 3. In Cassandra, since we are setting up a single node cluster, we tend to say, at the first thing, we tend to install it. So the single node cluster we tend to set up when we install it. So probably by default it is 1, because there are no multiple nodes to it. So there is no point having an application factor more than 3. So in that case, I think it is 1, but I'll have to double check whether it's 1 or 3. Okay, I think Cassandra is intelligent enough to decide it, so it gets 1 automatically because there is only one node to store. So there is so now so as we said, cluster is in the form of a ring. So Cassandra basically has this logical picture in the mind. Cassandra daemons have this logical picture. It considers all nodes to be part of a ring. It will be basically, all the nodes will be arranged in the form of a ring, will be connected to two more nodes, and this is how it works. It's a logical assumption from Cassandra. It will assume it to be in a ring. So when you say replication factor of 3, okay, so you say replication factor of 3, how does it chooses the, which node it will choose to replicate the data? Okay, so that is one question. And the first data, the first replica, where will it go? So these are the two questions that comes to my mind when I talk about writing data to like Cassandra. You can connect to any node, but you want to write data. So how does it decides which node will get the primary copy of the data, and then the data will be replicated from that node to various other nodes? So the first copy is decided by the partitioner you give. So there is something called partitioner. It is not on key space level. It is a cluster level, I think. So you can define on a cluster level which partitioner you want to use for your data. So you'll say you want to use random partitioner. Normally we tend to use random partitioner because it makes sure the data is equally divided in all the nodes. All the nodes are balanced in case of a a random partitioner. So we tend to use a random partitioner. So in this, what happens is it will divide your key space. It will divide your nodes into different key ranges. So it will assign certain key range to a particular node. So it basically generates a hash, and the hash ranges from 0 to 2 raised to power 127. Let's assume it generates a hash from 0 to 100. Okay, and you have four nodes. Okay, and it will divide the key space such a way node 1 will get 1 to 25, node 2 will get 26 to 50, node 3 will get 51 to 75, and node 4 will get 75 to 100. This is the way it will divide it. We are talking about random partitioner. Okay, this is how it does it. It calculates a hash, and then depending on the hash it has already assigned the key range, so it will just basically force the record in that particular node. So that's how. So as of now you can understand, partitioner will decide where the first copy of the data will go. Okay, so that's what I wanted to convey. Partitioner will decide which node will get the first copy of data, and then once that node has got the first copy of data, how will the replicas be decided? Which nodes will be picked up for the replicas? Okay, so which node in the cluster will be picked up? So that is decided by something called replication placement strategy. There are two by default strategies available in Cassandra out of the box. One is simple strategy and one is network topology strategy. Simple strategy, as the name suggests, it's not network aware. It's basically network unaware strategy. It doesn't know about your network. It doesn't know whether there are different data centers, whether there are different racks. It doesn't. It just assumes your network to be single rack only. So it doesn't differentiate between a rack and data center in case of simple strategy. Whereas in case of network topology strategy, it basically understands your network may have different data centers, and at the same time your each data center can have multiple racks also. So that's how it understands it. You can define it on your own. We'll talk about it, how to define your data center and how to define the racks. You can define it, but we'll talk about it in later modules. Okay, and then there's something column family. The key space can have multiple column families, as we said. Okay, now let's come to column family. So what does a column family, sorry, so what does a column family means? So column family is nothing but similar to a table in RDBMS. Okay, so it basically a logical division of the associated similar data. So basically the similar data you tend to store similar data, as in there is some subject or some kind of data which is similar in I mean, suppose you have a order data, so all the order data will be stored in single column family. Okay, so you can have order ID as a row key, and then you can have various columns like what product were bought as part of that order and all the stuff in to be stored in that particular column family. Okay, to give you certain examples, one is user column family. So user column family will be like you have user ID as the key. So user ID can be something like 123, or you can choose your any user ID, your Gmail ID, like Kunal at the rate Adureka. Okay, so that can be one user ID. So any of the user ID can be the key. It can be string, it can be int, it can be anything. So and the columns can be like, yeah, name equal to Kunal, city equal to Bangalore. These can be the columns. So columns are name and city, and the column values are Kunal and Bangalore. Okay, and there is a second column family, cricketer column family. So you can store the cricketers stats in one column family. You can have, say, Sachin Tendulkar, then you can say number of centuries, I mean, like number of centuries in one day international, number of centuries in test cricket, and then you can store the stats in that. Okay, you can have any number of columns for us, like one cricketer, any number of columns, millions of columns. If you see the stats, we have different stats we have for a cricketer. It can be like so many stats. They can have some some stats pertaining to their pre-university or university cricket. They can have some stats in domestic. They can have some stats on Ranji level. They can have some stats on international level or some other level as well, right? And whatever information you want to store, you can store it in the same column family. In one column family you can have millions and millions of columns. Okay, so as we said, a key space is a container of column families. A key space is a, so basically cluster is a container of key spaces, and key space is a container of column families. So column family types. So there are column family which is nothing but a table, which is basically analogous to a table in a RDBMS world. So there are certain types to it in Cassandra. So these are just logical types. So don't think about it being hardcore. We can move from static to dynamic, dynamic to static anytime we want. Okay. So static column family is like static column family is a column family wherein you define the column names and the data types up in front. So when you create a column family, you have an option to define the column names and column data type as well. You can define it. There is no restriction on that. You can define it. In that case, it will work more similar to a relational database table. So which is called a static column family because we say the columns are kind of static. Okay. So columns are kind of static. We know what all columns will be there, and these are the names. There is no keyword called as static in while defining it. You just say create column family in both the cases. Whether it is static or dynamic, you don't say whether it is static or dynamic because if you create a column family to be static, you can anytime add new columns also on the fly. You can add any new columns as well. So it can be combination of static as well as some dynamic. Okay. So a dynamic column family is where you don't define the column names up in front and you use the Cassandra's ability to use arbitrary application supplied column names to store data. Okay. So this is what you mean by dynamic. So dynamic helps in a way because in kind of unstructured data and all, the most of the times we use dynamic column family, which helps in basically taking care of any new fields or any extra fields that might have been added later. We can just go ahead. We don't have to code for it. It will automatically handle that. You don't have to go manually and add a new column and all that stuff. It takes care of it automatically in case of dynamic. Okay, makes sense. So static and dynamic are just for logical representation. There is no keyword like static and dynamic while defining a column family. So you have a static column family and you want to add any new dynamic column family in your code while loading the data, you can add. You can add dynamic columns anytime you want in a static column also, static column family also. There is no such restriction. It's just that there are two options. One wherein once you can give the column names and the wherein you can choose not to give. Cassandra doesn't. The only point of giving this differentiation is just to explain. Cassandra doesn't force you to give column names. You can choose to give column names, or you can choose not to. It's like entirely a developer's wish to do it, the way he or she wants to do it. Okay. So what are the differences with RDBMS? Cassandra column family is schema free. There is no schema to it. As we said, we can add any number of columns at any time. It is schema free. That's the best I think the feature in Cassandra by which you make your things very much scalable. Okay, so Cassandra column family has two attributes, name and comparator. So when you define a Cassandra column family, you have to give a name to it. That is something very, I mean, that is something mandatory name. And then there is something comparator. So comparator is basically data type for the column names. So comparator is nothing but data type for column names. If you don't specify the comparator, it will just assume it to be some default comparator, I think, which is bytes type. Okay. So name you have to give, which is mandatory, and comparator you can choose to give, which is nothing but the data type for column names. Okay. And Cassandra also has a concept of super column families. The super column families we'll discuss in detail later in point now. It is basically a super column family will use a super column internally. Super column is what? Super column is nothing but it is a like logical grouping, one more level of grouping of columns. So in a user column family, okay, you can have two super columns saying user personal information and users some like users product information, like what product he bought and all that stuff. So one super column can be personal information and it can have some attributes like some columns like name, city, address and all the stuff, and there might be some product specific product behavior like which product he's using, which version of product, which flavor of product and so on. So we will discuss in detail in next slides. Don't worry about super column families as of now. Column. So what are columns here? So column is basically a smallest increment of data in Cassandra. So there are three components to a column. We have name, name of the column. We have value, value of the column, and then we have timestamp. So timestamp is something that is generated automatically from Cassandra. It is it is a UUID generated out of a timestamp. I will explain what UUID means. It's a unique identifier of timestamp. Timestamp. So this is how the timestamp looks like. So where does this timestamp is used? So it is used in say various conflict resolution and all. We will discuss in detail later in later point in time where we make use of timestamp. So timestamp you don't have to worry about. You cannot actually edit the timestamp. Cassandra automatically inserts a timestamp on its own. It's an internal mechanism to see when this data, when this column was updated last time, updated or inserted. Clear? So for a user say for a user ID say 123, there can be a column column name is name and the value is say K Peterson and there's a timestamp which was generated automatically, which is nothing but a timestamp of the Cassandra cluster, Cassandra nodes. And then there's something called expiring columns. So you can declare some columns in a static column family to be say expiring. Even in dynamic also you can create, there is no restriction. So in dynamic also while creating new column you can say these column is expiring. So will what will that mean is you'll give a expiry date to that column. There will be a third field which will say expiry date. So after that date, that column value name and that column itself will be deleted from that particular row. If you say the phone number, let's say not phone number, what can be the actual example? Let's say some promo codes you are running. Okay, you want to associate a promo code with the particular user ID and you want to give a validity to it. Say this promo code is only valid till 20th February. Okay, so you will give the expiry date as 20th February. After 20th February that promo code will go out of your system. It will automatically will be deleted. Okay, so then there is something called counter columns. So counter columns are nothing but to basically maintain the counters. So you can increment and decrement those counter columns. So that is also there. We will talk about it in next slides. What are exactly counter columns? So there is name, value, and timestamp by default there that you have to give name and value, and timestamp it automatically takes in case of a column. So what is a super column? So super column families basically internally contain super columns. Okay, so a super column family is a column family which has super columns. Okay, so super column is nothing but a grouping of different columns altogether depending on some business need or depending on some logical grouping. Okay, so it's a kind of another level of nesting to the regular column family structure. It's a next level of, it's a one more level of hierarchy in case of a column family structure. You have key space, you have column family, then you can have a super column, then you can have column. So it's some one more hierarchy in between. Okay, so super columns are comprised of column name and order map of sub columns. So let's take an example of student. Okay, so student, so what type of information you can store? You can store the personal information of student like father's name, roll number, address, all that information which is very much personal to a student. And then you can store the academic details like like how much marks he got in last semester, what was the CGPA, and all the stuff you can store it. That also, like what was the marks obtained in science, maths, and all that stuff, right? So this is more of a university information or a academics information. So in that case you tend to create two super columns. One will be personal information. So that is one super column. We say personal information is the name of that super column. Okay, and then there are columns. Okay, there are columns which are like name, address, city, and all the stuff, which are the columns in a super column. Okay, and there can be another column saying academics, and then you can have the marks stored in different columns saying semester 1 percentage say 60%, semester 2 70%, semester 3 65%, and so on. So you can have different columns and values under that super column. So the what is the primary use case for super column? Is it to denormalize multiple rows from other column family into a single row? So you have two column families. Say you have student personal info as one column family and student academics as another column family. You'll merge both of them in one column families by creating two different super columns. So initially it was only columns. There were no concept of super columns. You have student info. There was one column family. There was no super column in that. There was one student academics, one column family, different. Both of them different. No super columns. You wanted to merge both of them. You wanted to keep it at one place only. Why to go? I mean, in case you want both the information, you have to go to two different column family to search. You don't want to do that. You just want to pick everything all together. You want to pick personal information as well as academics at the same time. Okay, so in that case what we'll do, you'll keep them in a super columns structure in one super column family itself. So this is what we call as materialized view data. So this is a type of a materialized view only. This is what we call materialized view in case of Cassandra. Okay, so materialized view is also covered. So this is materialized view when you combine multiple column families into one column family with the use of super columns, then we call it as a materialized view. So okay, what's the use case of a super column? So let's have a look. So when you try to book a ticket from Expedia, what do you do? Or any other travel site, what do you do? So there are two options. You can either choose international flight or you can choose a domestic flight. When you might choose to fly from Bangalore to Delhi, or you may choose to fly from Bangalore to London, let's say, right? So that's how you make your choices. So now when you choose international, as from you want to choose international from the drop down flight type, there will be some flight type here like this shown here. So which is either international or domestic. So why do you want to store all the information in one column family? You'll have domestic, domestic information in one super column family in one column family, and say you have international in one column family, right? Right. This is how will you will store. Or the other way is you store that information at one place only. Okay, you have that information stored in one place only. The key of that column family is leaving from the city you are leaving from will be the key, and then there will be two different super column families. One will be domestic destination and then will be international destination. So the source can be same in both the cases, whether it's international, whether it's domestic. You are leaving from Bangalore, right? And then you'll choose whether you want to go to London or whether you want to go to New Delhi, right? So you have your row key as Bangalore. I mean, number of, like, it will be the name of city, Bangalore, London, whatever. Then from Bangalore you can choose either you want to choose, either you want to go to you want to travel internationally, or you want to travel in a domestic flight, right? So depending on your choice, it will go to a particular super column family only to get the details. This is how you'll model the data. For Bangalore city, say for Bangalore city, you'll have two super column families. The row key is Bangalore. You entered the super column family through Bangalore, and you said, give me international destination, give me the data about international destinations, which can be anything, right? So depending on the first drop down, so you gave London here. Depending on the first drop down, the options here will be decided. So suppose from London there is no flight to say New Delhi. Suppose there is no flight to say New Delhi. So then the international destination will not show up as New Delhi. It won't detect it at all. So what is the limitation of super column, as well as I was saying? So one limitation of super column is that all sub columns of a super column family, or sorry, of a super column must be deserialized in order to read a single sub column value. So what does that mean? So let's go back to previous slide and let's see. For this super column, say for this super column, you had different attributes, say departure time, price, and all that stuff. So you cannot say give me price. If you say give me price for this particular super column, if you say that, in this case, what will happen is it will deserialize everything. So it will write everything to a backend system and then give you price, because these names are not indexed. So these column names are not indexed. It will have to deserialize the whole super column. So you guys know what deserialization and serialization mean. Deserialization is basically more of writing the data. I mean, in Java terms, basically writing your class content to a file. So it will have to deserialize everything. So you have, say, 10 columns in a super column. So in case of student, Let's take in case of a student, there was a super column called student personal info, and you have name, address, and everything. If you say give me address, if you say give me name, so it will deserialize name, address, everything first of all, okay, and then it will return you the exact column you are looking for. Whereas in the case of a normal column family, which is not super, it will just it will just deserialize the column you want to get out of it. Okay, so that concept is clear. What exactly it means? Why we shouldn't be using super columns? So if you have a set of columns in a super column, you have to deserialize everything to get a particular column. You cannot choose a column from super column. So even if you choose, it will end up giving you, it will end up processing everything at the back end and then giving you the column you need. But there will be some time wasted in that, right? So there is a limitation associated with super column. So column data types, what are the different data types available? So we have ASCII type, we have bytes type, lexical UID, long integer UTF-8, timer UID. These are the different data types available. So you can read more about them in case you don't know. These are the basic data types I think available in all the in Java also everywhere, right? So you can use this. And validator, what are validator? In Cassandra, data type for a column value is called a validator. So the column value or row key. So any value that we give, row key is also value, and then there's something called column value that we give. So you'll give a name for a student, which will be name for a student will be some Kunal or something. So that values data type will be given by the validator or the row keys. Row keys validator. You can sorry the row keys data type you can give from the validator. Okay, that's what we call validator in case of Cassandra. Column values data type as well as row keys data type we call it as validator, and comparator is the column names data type. So comparator is column names data type. So the name, the column address is also a column name. So address data type basically. Okay, so you can have some date or anything also, right? In case of column names, you can have date also in case of column name. That's also in kinds of in case of a dynamic cluster, dynamic column family. I mean, you want to store some kind of time series data. You can have date as a column name also. That works perfectly. That is one of the use cases of Cassandra to store time series data. So you have wide, I mean, kind of rows you can have. You can have wide rows, huge number of columns, and several rows. So you may have millions of rows and columns. That's not an issue. I mean, columns you can store some kind of time series data. Say, in case of Expedia, the flight prices change every hour. Let's assume a flight price changes every hour for a particular flight. Say for a particular flight, you want to store the prices. You want to maintain the history also. So what do you do? So say 1st February at 8 o'clock, the price was uh, so the price was say $50. So you'll name the column name will be 1st February 8 o'clock, and the value will be say $50. Okay, so then the second column will be at 1st February 9 o'clock, the column value is $60, and so on. So you can have millions and millions of columns that way. Okay, so skinny rows, small number of columns, so you may end up having only 10 or 20 columns, or like hundreds of columns, not like millions and millions. And you have many different rows, you have billions of rows in that case. So you can plan how to model your data depending on the business needs. You can choose between wide rows and skinny rows. Both of them are very well handled with Cassandra use cases. Okay, both are the both basically Cassandra suits for both wide rows as well as for skinny rows. There is no issue with any of these types of rows. Okay, a composite key. So what is a composite key means? The composite key consists of one or more primary key fields, right? So I mean, in case there is no there is no row key. So suppose you want to set the row key as city, right? So city can be same city can be there in two different country also, right? So there is Punjab in India as well as Punjab in Pakistan, right? So there are some cities also that which are common between India and Pakistan, right? So you have to append either state name or the country name to the city. Say you want to say Bangalore.Karnataka.India. So this is a composite key in that case, because you are using city state combination of city state and country name as a key. City is not a key because Bangalore can be there in some other place as well. There are some cities which are kind of duplicated. So in case your user ID or username is not unique, username, so what you'll do, you'll use user first name dot last name dot age. Probably for like for your application this combination is unique. Probably it can be, I mean you can think of modeling the data that way, but that cannot be the scenario. It's not actually unique, but in some cases it can be unique, right? Or you can have some father's name, something associated with that to make it unique, right? So that's how you model the data. I mean, you can have the composite key also defined. That's fine. It's basically the concatenation of two different keys. As simple as that. So there are other concepts. Materialized view we already explained, right? So what materialized view is? So it's nothing but merging two different super columns. So sorry, merging two different column families into one column family using two different super columns. So you had one column family student info, you had one column family student academics, and you merged both of them in single super column family wherein you tend to create two super columns. One is student info and one is student academics. Okay, this is how you create materialized view in case of Cassandra. So there is second concept of valueless columns. So what are valueless columns? So suppose let's take you want to take number of users in a city. You want to just get that information, or you want to just get the distinct users in a particular city. Just you want the user ID. There is no requirement to get the username and all. Only user ID you want to select for a particular city. So how will you model your column family in that case? You will have the row key as city, say Bangalore, and the user ID will be the column names. So there will be a column called say Kunal, which is the user ID. Okay, then there will be a column called Ravikant. Say it will also be a user ID. This is itself is the name. So name itself is the user ID. Okay, or rather user ID is the name only. I mean there is no the column name like user ID equal to this. The column name itself is Ravikant or Kunal or whatever. Okay. So in that case, value will be blank. You can choose to have the value as blank because you only need the column names. You don't need the column value. You want to just say, give me the distinct user for a city. So this will return you distinct users for a city. There is no need for the value. There is no requirement for the value. You can choose to store some value. You can choose to store name also for that user ID in the value. That's fine. But there can be requirement wherein you just want to choose the user ID. So this is how you do it. So that is clear. So what do we mean by valueless columns? So city getting the number of distinct user per city is the best example of a valueless column.